Okay. Okay, so here we go. So the answers to these questions about the why questions are always the same, depending on which one you're. So depending on which direction you're moving. So the first thing you have to figure out is what kind of trend you're talking about. Are you talking about a periodic trend or a group trend? Are we talking about what happens as you go across the period, or what happens when you go down a group? Okay. That's the first thing you should decide. What am I comparing? Okay. And the reason, well, if it's a periodic trend, the reason is going to be because of nuclear charge. Extra protons pulling. If it's a group trend, it's going to be because of energy levels and shielding. And when you're answering why questions, I need to see that you understand what we're talking about in the atom. What are we measuring about that atom? What happens to which electron? So the answers are basically pretty programmed. Okay? You don't use the same logic over and over again. The key is to know what you're talking about. What are we measuring? We measure ionization energy. What are we measuring? We measure electronegativity. So actually, you can actually program the sentences where you make one decision and all of your answers flow from those one decision. Make one choice. That first choice, is it a period or a group trend? So this is what it could look like. Okay, the trend could be either as you go across a period or you go down a group. Okay, those are two possibilities. Across a period means left to right, down a group. So you're talking about which direction you're moving. Then you can talk about a reason. Well, the reason, if it's across a period, is going to be about nuclear charge. The reason, if it's down a group, is because of energy level and shielding increasing. So when somebody asks you to explain why, you can start off with these first two clauses. As you go across the period, the nuclear charge increases, or as you go down a group, the energy level and shielding increases. And you've got the reason right there, just have to tie it into what's happening in the atom. So what kind of results do we have? Well, we can make the electron either harder or easier to remove. If the nuclear charge increases, the top choice, it's going to be harder to remove the electron because you've got more opposite charges. If the energy level and shielding increase, it's going to make the electron easier to remove because it's less attracted because of the shielding. So that would be the case if we're talking about ionization energy, because removing an electron is ionization energy. Okay? You can either make it pull more or less on the other atom's electron. If you got extra nuclear charge, extra positive is going to pull more. If you've got extra energy levels and shielding, it's going to pull less on the electron. And you talk about the outer electrons being more or less attracted. And that would be about size. The more attracted they are, the smaller they are. less attracted they are, the bigger they are. So this is all just a review. Aiden, Jacob. This is all just a review of what we talked about last week. And then you're going to make a conclusion. So the blank is blank. So the electronegativity is lower. So the ionization energy is higher. But all of it stems from that first choice. So what do I mean by all of it stems from the first choice? Well, let's try it for the group trend in ionization energy. The group trend in ionization energy. So what would our explanation, tell me what the group trend is and explain it. As you go, well, I want the group trend in ionization energy, so it's going to be down a group. As you go, down a group, the nuclear, no, it's not about nuclear charge, is it? Group is about energy levels. The energy level in shielding increases. Okay. And which one of these is about ionization energy? Which one of these processes is about ionization energy? What does ionization energy measure? The energy to remove an electron. So it's got to be a top one, and making the electron easier to remove. So the ionization energy is lower. See how the pieces fit together? Once you pick period, you've picked the reason. Then you have to just understand what you're measuring. Okay? So let us try the trend in electronegativity. Let's try the periodic trend in electronegativity. What happens to electronegativity as you go? As you go, it's periodic across the period. The nuclear charge increases. More protons. And which one of these is about electronegativity? And electronegativity is pull on the other atom's electron. So it's going to make the pull, well, if I've got extra nuclear charge, it's going to pull more. More opposites attract more on the other atom's electron. So the electronegativity is higher, with one minor exception for electronegativity. Noble gases don't have an electronegativity. Look at that.